Hello, my name is Bilal Ashur. Today I'm going to present a project for predicting temperature in London. So let's get started. So in the beginning we have to import the necessary and the main libraries so we can work in this project. So as we can see here we have Panda and NumPy, it's for manipulation, and we have MLflow for tracking, and for visualization we have Matplotlib, and we have Seaborn, and for machine learning we have skitlearn. So we're gonna use these libraries to work on this project. In this section, as you can see, in the first line we start by importing the necessary libraries. Here we use Panda for data manipulation, and the data set is loaded into a data frame. It's named weather, and in the other line we use info to get overview of the data set. So here in this section we have the date column in the data set, and as we can see it's a string format, so we convert it into a date time by using this function, and we are specifying the format as this. Then after converting the data we extract the year and the month from the data, from the date column, and we create a new column, year and month. So this will allow us to perform time-based analysis later on. As we can see here, this is the output for the previous code. As we can see here, we defined a list of weather that we are interested in, like cloud cover and sunshine, global reduction, etc. And then we use the group by method. We group the date by year and month, and we calculate the average value of each of the specific matrix, and the result will be in a new data frame. In this section we use Seaborn to create a line plot, and the line plot function plots here on the x-axis and mean temp on the y-axis, so we can visualize the trend in mean temperature over the years. And here to understand the relationship between different weather matrix, we create a heat map, and using this heat map will help us to identify strong relationship that may be useful for predictive modeling. Here we can see the output for the previous code. So as we can see here, we have the graph for the mean temp over the years, and in this output we can see the clouds and the sunshine that we use over the month and year and the other data sets, as we can see. Here we select a subset of features that we believe it will be important for predicting the temperature. So these functions, these features are month, cloud cover, sunshine, etc. Then the target variable we aim to predict is mean temp, and to ensure that our target variable does not contain any missing value, we use the drobna method to remove any rows when mean temp is null. Here we separate the features and the target variable into two different data frame, X for features and Y for the target variable. And to evaluate our model performance, we split the data into training and testing. For testing we have 33% of the data, and for training we have the remaining 67 data set. And the random state parameters ensure that the split is reproducible. To handle any remaining missing value in the feature, we use the symbol inputter, so we can replace the missing value with the mean of the respective features. And after the imputation, we standardize the features using the standard scalar. This scales will have a mean of 0 and a standard deviation of 1, so which is essential for many machine learning algorithms. In this section we train three different models: linear, regression, decision tree, and random forest. For the decision tree and random forest model, we experiment the different maximum depth to see how model complicitly affect performance, and we use MLflow, so we log each model along with its parameters and matrix, and for each model we log the root mean, squared error, which measure the difference between predictive and actual value, and a lower RMSE indicates a better model. This approach allows us to track and compare the performance of each model and easily identify the best one. After training and logging our model, we retrieve and display the result of the model run using the MLflow search.run function, so we can run the experiment result, and this allows us to compare the RMSE value for each model configuration and identify the best performance model. By analyzing the result, we can make informed decision about which model to use for predicting future weather. This is the end of the presentation. Thank you.